Yeah. So yesterday we saw how to derive the yesterday we saw how to derive the trapezium rule, and now today we want to know the specifics of how to use that formula to calculate the approximate value of any integral in applied math using the trapezium rule. So we said yesterday that if this is a curve, our curve is y is equal to f of x, and you would wish to find the area which is bounded by this curve, and the x-axis from x is equal to a to x is equal to b. We have these y values which come as a result of substituting the x values in the original function. Now these y values are referred to as the ordinates in this topic, and the spaces between the y values are referred to as the sub-intervals or strips. So our first y value is y0, the second one is y1, the third is y2. If you have 1, 2, 3 y values, it means you have 1, 2, 3 ordinates. Now every time you have a space between two y values, you're now forming a sub-interval. So if you have 1, 2 y values or ordinates, it means you have one sub-interval. If you have 1, 2, 3 ordinates, it means you have 1, 2 sub-intervals. So the y values are the ordinates, and then the spaces between the y values are the sub-intervals. So we are generally saying that for any sub-intervals, if you have one sub-interval, if you have one space between the y values, it means the y values are 1, 2. If you have two spaces between y values, it means the y values are 1, 2, 3. So for n sub-intervals, we have n plus 1 ordinates or y values. So for 8 sub-intervals, it means if you have sub-intervals and you want ordinates, you add 1. So for 8 sub-intervals, we have 9 ordinates. You will think about for 7 sub-intervals. Now similarly, if instead you have ordinates and you want to get the sub-intervals, this time you will subtract 1 to get the sub-intervals. So for 8 ordinates, we have 7 sub-intervals. And then for 7 ordinates, you will think about how many sub-intervals are there. Now sub-intervals are the same as the strips, like we have said. Then the other thing is that in the questions that we are going to deal with, if the question has not specified the number of decimal places the final answer must be written to, it means when we are recording the values of y in the table, we shall be recording them to beyond 4 decimal places, because our final answer will go to 4 decimal places. Then if the question wants the final answer of the integral using trapezium rule to less than 4 decimal places, maybe to 2 decimal places or to 3 decimal places, then we record the y values to a minimum of 4 decimal places. That is what is composed in our fourth note. In the fifth note, like we said yesterday, we shall always be finding this h from the upper limit of the integral minus the lower limit of the integral divided by the number of sub-intervals. So if you're given ordinates, you have to find the sub-intervals. Now after getting this value of h, that h will either be a terminating decimal or it will be a non-terminating or recurring decimal. Now if it is a non-terminating decimal or recurring decimal, it is better to take or to use the fraction. But where the fraction gives a terminating decimal, then it is better to adopt the decimal. So that is the essence of this note, that after getting h, you examine that h. If h is a non-terminating decimal, if after putting that fraction in the calculator, the final answer does not exhaust the entire screen of the calculator, that is what we mean by a terminating decimal, then you can use it as h. But where the final answer exhausts the entire screen of the calculator, then it will either be a non-terminating decimal or a recurring decimal. So in that case, we use a fraction instead of that decimal. Now, the sixth note says that the trapezium rule gives us the approximate values. Like we said, we draw different trapeziums here, and then we go ahead and find their areas. So we sum up those areas and we get the area which is covered by the curve, and the y which is covered by the curve and the x-axis from a particular x value to some other x value. So this gives an approximate value, as you can see clearly, that as a result of extracting the trapeziums, there is some other area which is left out and some other area which can be included in the course of drawing the trapeziums to completion. So it is from that basis that we say that the trapezium rule gives an approximate value, and then the other formulas of integration, the other formulae of integration from the pure math will always give you the exact values. So that is all about our next note. Then the last note is about improving accuracy. So if you want to improve the accuracy or to minimize the error in your final answer, these are our trapeziums that we have drawn. If you want to reduce these spaces which are excluded and also included, it means you draw these lines as closer as possible to one another. And if you draw them as close as possible, it means you are creating many sub-intervals or strips. But as you're creating many sub-intervals or strips, you will also be increasing the number of ordinates. So if you want to minimize the error, for example, for this first area, we shall draw this when it is close to this, implying this one will also move closer. So to minimize the error, we minimize the error by increasing the number of sub-intervals or strips, or we can minimize the error by increasing the number of ordinates. Thank you for listening.